Welcome to The Explainer. Today, we're diving into something pretty cool, an AI called ChemAgent. It's not just solving tough chemistry problems, it's actually learning how to solve them, kind of like a human student. So, let's break it down.
All right, so let's get right into it. We all know that large language models, LLMs, they're incredibly smart, right? They can write poetry, they can code, they can answer just about anything you throw at them. But when you get to the really hard sciences like chemistry, they often, they flunk. The kind of pinpoint precision and the step-by-step reasoning you need, it's just a whole different ballgame.
And this slide just lays out the problem perfectly. It's like a tale of two answers. Over on the left, that's your standard LLM. It kind of gets the gist of the problem, but look at all those little mistakes. A wrong constant, a messed up unit conversion, and boom, the whole thing spirals into a totally wrong answer. The researchers actually called this cascading failure. But then you look to the right, and that's ChemAgent, just a clean, step-by-step, correct solution.
And we're not talking about simple typos here. These LLMs get completely tangled up in the nitty-gritty details. They'll grab the wrong formula, or they'll make these weird logical leaps that no human scientist would ever make. Sometimes they even write buggy code to do the math. All it takes is one tiny slip-up, and the whole house of cards just comes tumbling down.
So, seeing this happen over and over again got the researchers thinking. They asked this really simple but brilliant question. If these super powerful AIs are failing, how on earth do we humans get it right? And the answer, it turns out, is all about how we learned.
Think about it. We don't just tackle every new problem completely blind. We practice. We learn from our mistakes. We scribble down good notes on what actually worked. And over time, we build up this huge mental library of experience that we can pull from later on.
And that right there, that's the light bulb moment behind ChemAgent. It's basically a framework that gives an LLM its own dynamic, self-updating study guide. This isn't just some static database, It's more like a living, breathing library of solved problems and winning strategies that gets bigger and smarter with every single question it tackles. Yeah, and this quote from the paper just nails it. It says, much like humans improve their skills through practice, these systems benefit from continuous exposure to new tasks. So the goal isn't just to make an AI that can spit out an answer. It's to build one that actually learns from everything it does. Getting better and better with experience, just like a real student cramming for an exam.
Okay, so how does this AI student actually hit the books? Let's pop the hood and take a look inside ChemAgent's brain to see what's going on.
Well, it follows this really logical four-step process, pretty much exactly what a human expert would do. First, it breaks the big, scary problem down into smaller, bite-sized pieces. Then, it digs through its library for memories, basically notes on how it solved similar little problems in the past. It uses those notes to build a solution. And then, and this part is absolutely crucial, it adds the new solution back into its library. It's making its own study guide stronger for the next test.
And this library isn't just a messy pile of notes. No, it's super organized into three kinds of memory. And the student analogy here is just perfect. You've got planning memory, that's like your high-level study plan. Then there's execution memory. Think of that as your binder full of completed homework problems you can look back on. And finally, knowledge memory, which is basically its trusty formula cheat sheet. And get this, it even has what they call an evaluate and refine module. So after it comes up with an answer, it actually stops and checks its own work. It's looking for errors in units, in the math, and the logic, and if it finds a mistake, it fixes it before giving the final answer. How smart is that? It's literally proofreading its own homework.
All right, so enough about how it studies. Let's get to the report card. Did all this work actually pay off? How did our AI student do on the test?
Oh, it didn't just pass. It completely aced the exam. I mean, the results are just stunning. When you take the ChemAgent framework and apply it to a heavy hitter like GPT-4, its accuracy on some chemistry tests shot up by as much as 46%. That is not a tiny little bump. That is a total game changer.
And this chart really puts that number in perspective. Look at that first bar. That's the standard GPT-4, just trying to reason directly. It's struggling, way down below 20% accuracy. Okay, now the middle bar, that's the previous best-in-class method. It does way better, almost 48%, but then look at ChemAgent. It blows past both of them, hitting over 57%. That's a huge leap forward.
And what's maybe even more exciting is that this framework doesn't just prop up weaker models. It's like a turbocharger for the best ones. The research shows that the smarter the original AI is, the bigger the boost it gets from ChemAgent. So it's taking the valedictorian of the AI class and making them even smarter. It's pretty incredible.
The paper has a great name for this: self-evolution. This system is never standing still. Every single problem it cracks just adds to its memory, making it better equipped for the next one. The more it practices, the smarter it becomes. It's that simple.
So, okay, let's zoom out for a second. This is way bigger than just an AI getting good grades on a chemistry test. I mean, think about it. A system that can reliably and automatically handle complex scientific reasoning, that has absolutely massive implications for the real world.
I mean, the ability to reason through messy, complex chemical problems is the bedrock of so many critical fields. We're talking about the potential to supercharge drug discovery, or to help us invent brand new materials from scratch. It could automate all the tedious research tasks, which would free up actual human scientists to tackle the really big, creative questions.
So I think if there's one big takeaway here, it's this. By teaching an AI to learn the way we do, through practice, by keeping good notes, and by checking its own work, we're not just building a fancier calculator. We're creating a potential new partner in the lab, a partner in scientific discovery. This is a tool that doesn't just give us answers. It actually learns and grows right alongside us. And that leaves you with a pretty exciting question, doesn't it? What huge scientific breakthroughs could an AI chemist like this help us unlock next?